Hi, it's Professor Adam. Let's talk about chemical kinetics and rates of reaction. Rates are frequently encountered in everyday life. For example, the speed of a car is measured in units such as kilometers per hour, and water flowing from a tap can be measured in liters per minute. In the case of chemical kinetics, reaction rates are measured as the change in concentration over the change in time. Rate of the reaction can be calculated by measuring the absorbance of light by a solution per unit of time, such as the decomposition of a food dye after addition of a base. This can also be seen in the decomposition of nitrogen tetraoxide to nitrogen dioxide. The rate can be described as the rate of change in the products over the rate of change in time, or the change in concentration of the reactant over the change in time, though this is negative because the reactant is consumed in the reaction. Remember that the brackets mean concentration of, and the triangle is the Greek letter capital delta, which means change in. One nitrogen tetraoxide disappears for every 2 nitrogen dioxides that appear, so nitrogen dioxide appears at half the rate that nitrogen tetraoxide disappears. Measuring can be done in different ways. For example, as seen earlier, the amount of light a substance absorbs can be measured. Or if the product of a reaction is a gas, the change in gas pressure can be measured. Change in concentration is being measured, and so concentration versus time can be plotted. From this data, the instantaneous rate, the rate at any given moment, can be calculated. This is done by calculating the slope of the tangent at that point. The average rate between 2 points in time can be calculated as the difference between the concentration at times A and B over the time interval. If, for example, the change in concentration over 15 minutes was 0.15 moles per liter, then the average rate would be 0.01 moles per liter per minute. The reaction rate can be written in terms of any product or reactant, but stoichiometry must be considered. For the general reaction A plus B reacts to form C plus D, the general rate equation can be written as this, with the stoichiometry explicitly written out. Let's check comprehension.